Mike Eliason is here to give a presentation on mass timber and Passivhaus, two natural groups, industries that kind of fit together, certainly in my belief, but there's not enough of it's happened yet. So Mike, please begin your presentation and we'll take questions at the end.
All right, so I have titled my presentation Passivholz. This is taking the German Passivhaus plus Holzbau, wood building for a new paradigm of construction. A little bit about myself. I'm an architect here in Seattle. I've worked in Germany for a couple of years intermittently. Most recently, I took a trek to Bavaria for a year with my family. We thought it would be long-term, but it wasn't. And so we came back to Seattle. And I'm back with my previous employer, Patano Studio. Mass timber experience. So the first time I went to Freiburg was 2003, 2004, and the office was doing a lot of projects with Brettstapel, which is the German term for Dowel Laminated Timber. And so I was really exposed to some of these components years before, I guess, a lot of other people. And so they've always kind of been fermenting in my head. Over the years, I've done a number of proposals and competitions for mass timber buildings. And then in 2019, our office rebuilt a marina on South Lake Union here in Seattle that had burned down. And I'll share a couple of photos with that. And that was I guess the second installation of Dowel Laminated Timber in the US. So it was a nice little way to come full circle. Presently, I'm working on a 50,000 square foot mass timber project here in Seattle, school. And we also have a couple of projects that we're going to be aiming for on Passivhaus. So nothing right now that is super connected, but the hope is in the near future that'll be possible. We are a car-free family. We sold our car before we moved to Bavaria. We have 2 cargo bikes, 2 kids. And so we're really interested in like these really kind of new paradigms of living, right? Ultra low carbon, low impact. And so we're taking that a little bit to an extreme at times, but for now it's working. And then I took the Passivhaus certification training in 2010 with PHI and FIAS before they had their little split. And that kind of also really changed the way I looked at a lot of building and construction. But you know, mass timber wasn't really my first foray into sustainable building. My second year in architecture school, there was a design build studio, third year. And we were tasked with designing and building a farmhouse that had burned down. And it was an amazing experience. There's about 25 of us that, you know, just out on site every day, filling these walls with dirt, a little bit of cement, and then just compacting the hell out of them. And the end result was actually really quite elegant. I think about this project a lot. Haven't used mass timber in a long time. There have been a lot of innovation, rammed earth in a long time. There have been a lot of innovation in this field, most of it coming out of Austria and Switzerland, including insulated, prefabricated components that are just trucked into site, very similarly to mass timber, actually. But enough of that. So in 2003, my 4th year at Virginia Tech, they kick everyone out of the school. There's a travel program, there's a study abroad program in Switzerland, or you can go try to work in another firm. And so a friend of mine got me a job working in the lovely little German city of Freiburg, nestled right there at the corner of Switzerland, France, and Germany for a year. It was an amazing opportunity. It's where I was exposed to Passivhaus, mass timber, Baugruppen. The district of Vauban is 50% Baugruppen. I'll talk about Baugruppen a little bit later, but those are effectively urban co-housing projects. Vauban is not a big city. It's only about 220,000, 230,000. There's a university there. It's pretty old and historic. And I actually met my wife in Freiburg. So this place was really foundational to me as a professional and also in my personal life. And again, I have this yearning to constantly go back. And I think that's what actually drew us to try to go back to, that is what drew us to go back to Bavaria 2 years ago. So one of the main projects that I worked on in Freiburg was this duplex, and it's a little bit difficult to see, but all of this floor or wall here is polycarbonate with a mass timber. It's Dowel laminated timber assembly behind it, and I'll talk a little bit about why that is in a second. There were also a number of competitions at the time private commissions that were also incorporating mass timber, as well as several projects that were in design and construction that we're using. It was almost exclusively Dowel Laminated Timber, not CLT, and I think part of that was just the single element, right? So it's just wood, it's just dowels, there's no nails, there's no glue, and so the firm was really kind of intrigued by this. And so this duplex is basically, you have this mass timber and brick shell, clay block shell, that is surrounded by multi-wall polycarbonate, and it effectively acts as a greenhouse. And what's really interesting is that this duplex isn't two separate units. These are two units that kind of are intertwined, and they have these common spaces within the building where the owners can see each other, navigate around each other, and really dwell, I think, together much more than you would in kind of a traditional duplex where it's two separate buildings. So the Dowel Laminated Timber would be in the wall assembly here. And so the way this works is, in the winter, the polycarbonate shell, everything is closed off. It's basically like this micro greenhouse, right? It's a solar collector on the facade, and that heat can be pulled into the building. And there's two aspects of this. One, it heats up the mass timber very quickly because it's got a lower heat capacity. And so that warms up, and then that dissipates heat into the building over time. But then the clay block is kind of like the secondary factor. So then the clay block starts to absorb some of that heat and then releases it. And so you have this concept that it's a relatively low energy building. It's not Passivhaus, although it utilized HRVs and other aspects that you would find in a Passivhaus. Excuse me. And in the summer, you would just open up all of the vents in the outer wall, and so the greenhouse effect, the stack effect, would pull out all of the hot air, and you'd have ample cooling within the building. I haven't visited since it was built, so I'm not quite sure if it functions as designed. But a lot of the projects that I was working on at this time were kind of in this vein, and so it was a very different way of thinking, a very different way of approaching low energy buildings than anything I had ever seen. And so again, very foundational. And then over the years, I had to go back to finish my 5th year in Virginia Tech. We ended up back in Seattle afterwards, and I've been working here almost the entire time since. The mass timber and the Passivhaus has been playing in the back of my mind. So we worked on several competitions. We did several proposals for houses and small buildings, incorporating CLT and walls and floor assemblies. And then I ended up at Patano Studio. And Chris Patano is an American architect with an Italian heritage. And we're both just constantly talking about mass timber, the timber industry in Europe, design competitions, which are the primary form of project procurement in Europe as well. And so one year we decided, okay, let's just bite the bullet. We'll do a mass timber Passivhaus school competition entry for Italy. So we took a stab at it. It was very different for me because I had never done an Italian competition. I've done several German competitions. And so navigating kind of the ins and outs of, the different ways different countries, do their procurement was kind of fascinating. We didn't win, but it was an excellent adventure for us. We've also undertaken several studies here in Seattle for mass timber buildings. So this is a mass timber office building here in the downtown area. 6 floors, very simple layout, open floor plan, glulam framework, and just trying to play with the facade a little bit. And then this is the Dowel Laminated Timber Marina building that we rebuilt. It was initially designed for CLT. At the time, there weren't as many CLT manufacturers in the US. They were slammed, and I think the prices had gone up as well because they were so busy. And so we started talking to the guys at StructureCraft. They were amazing to work with on this project. The end result, I think, is incredible. I'm a huge fan of DLT. I wish that there were more DLT fabricators in the US so that we could have more options. But StructureCraft is, they're doing amazing work. And this is kind of a close-up, a little bit of a detail of that DLT facade or roof deck. The one thing that I will say is the DLT panels that we were doing in Germany never had a gap, or if they did have a gap, it was much smaller. And it took me a long time to come to terms with StructureCraft's construction tolerant, not tolerance, but it's just the gap that they require in their panels for movement due to moisture and stuff. But now that I see it, it's like I appreciate it. I understand why it's there, and I can live with it. But again, it was just a really, really elegant product. So now we'll switch gears, and I'll talk a little bit about Passivhaus. So Passivhaus is a German-ish standard that was invented or founded by Wolfgang Feist, who is based in Darmstadt, and Bo Adamson, who is Swedish. What's interesting to me is that the principles of Passivhaus are actually rooted a little bit in North America, in Canada specifically, but it's a lot of stuff that, you know, the way we used to build or the way that we could have built, and we didn't really follow through. The functional definition of a Passivhaus: a building for which thermal comfort can be achieved solely by post-heating or post-cooling of the fresh air mass, which is required to fulfill sufficient indoor air quality conditions without a need for recirculated air. What this means is that we're basically supplying the minimum amount of air that we need for hygiene, and that the heating and cooling that needs to be provided for the building can be supplied solely by that air. Typically, we have large forced air systems to supply adequate heat, so we're actually over ventilating, or we're having separate systems, radiant loops, etc., which kick out a lot more heat or air conditioners on the cooling side. So we have 3 requirements to meet Passivhaus. One is the space heating demand, or the cooling demand, has to be under 15 kilowatt hours per meter squared per year. And then this is based on the treated floor area, which is again based on a German standard. It's not the net area, but it's fairly close. It's also the specific primary energy demand, historically needed to be under or at 120 kilowatt hours per meter squared per year. Basically what this means is you take all of the energy that you use on site, you multiply it by a source factor. So if you're using coal-based energy or dirtier grid, then your source factor is going to be higher. If you're using renewables, it's going to be lower. And then you have to pass a blower door test. So your air tightness has to be under 0.6 air changes per hour. And so they have 5 recommendations for how to achieve this. One is Passivhaus windows. So these are triple pane windows. Europe has a long tradition of triple pane windows. I feel like we're still struggling in the US to get even double pane windows that are moderately energy efficient. The other is optimizing your thermal insulation. And so this is just balancing the heating gains and the heating losses, right? So we're minimizing heat loss through the facade. And there are a number of ways that mass timber, I think, is a really beneficial way of designing and approaching. There's also the reduction of thermal bridges. This is one that I think we especially need to watch in the Passivhaus community. And this is basically ensuring that when building components penetrate our exterior envelope, there's a thermal break, or thermal break between the two, so that we're not bridging heating or even cooling between the two and exacerbating heat loss. There are maintenance and durability issues with that as well. And you can kind of see that a little bit here. They have this balcony, and the balcony is thermally broken from the building and sitting on columns. I would say a good number of multifamily buildings in Europe, especially the low-rise, do this pretty well, and it's more than adequate. The other component is air tightness, and I'll talk a little bit more about that. That's how we achieve our blower door test. And so when you have a building that is completely closed up, right, you need to supply fresh air. So the HRV, the heat recovery ventilator, is kind of the lungs for the building. And what it does is it extracts the stale air. And while it's extracting the stale air, it's simultaneously pulling in fresh air from the exterior, filtered. It's taking the heat, and in some instances also the latent moisture out of that stale air, reconfiguring it to the incoming air, and sending that back in. So it's preheating or pre-cooling the fresh air from the stale air, so that you don't have to add as much heat or cooling down the line as possible. It also prevents being inundated with colder air when you're getting fresh air in your building. So triple pane windows, definitely component that is required in most of the world. In harder regions, you can get away with double pane. And I'll talk a little bit more about how we kind of figure some of that stuff out. But triple pane window, vinyl, aluminum, wood clad aluminum, or aluminum clad wood. There are a number of different options. China, I think, now has like 150 Passivhaus certified windows. The US has 2 or 3. And there's a big push for smaller and smaller windows, but you can still get pretty sizable windows in a Passivhaus. This is a Passivhaus kindergarten in Austria by Bernardo Bader, and incorporates some really interesting components, prefabricated exterior facades, and it's just beautiful. We don't make kindergartens like this in the US, and it makes me sad. For the air sealing, there are a number of different ways that we can do this. Membranes, tapes, fluid applied weather barriers, and gaskets. This is the Entelos, the Proclima membrane, the air tightness membrane, and the Tescon Vanna is their airtight sealing tape. And there are other different fab manufacturers, and they all have similar kind of components and lines. Proclima has these really nice gaskets, air sealed gaskets that you can apply. You know, they have just enough room for the roar, the ducts to come through, and you know, it's just a really elegant solution. This is the optimized insulation that I was talking about, and I wanted to show this picture because I think in the mass timber world, a lot of our insulation is going to be going on the exterior. This assembly, CLT wall, weather barrier. We would also have our taped, taping the seams here so that we get our air tightness as well. Exterior insulation. So this looks like 6 inches of mineral wool, which is pretty common in mass timber buildings as well for the fire, reducing the fire risk. And then we're just screwing battens to the CLT, and then we can apply our siding directly, excuse me, to that. So it's a really basic assembly, but I think it's super functional. The moisture risk is really low. The construction sequencing is really not that difficult. You could install all of these components in a factory, in a dry condition, and truck them out to site. And there are a number of organizations that are doing that now. And I think it's a really smart way to be building. The thermal bridges are the other thing to be avoided. Number of options available in Europe. Shock, I think, is the biggest one. They make a number of concrete to concrete, steel to concrete, steel to steel thermal breaks. This one is designed for concrete to concrete. And so you have this cantilevered concrete balcony, and then this is your concrete deck on the inside. They run rebar on either side to connect it all. But this is all insulation, right? So this is all preventing heat from passing from the interior or the exterior to the interior, or sorry, cold from going to the interior from the exterior. And so it's a really elegant solution. It's available in the US. It's starting to be used in the US. And you know, we need a lot more fabricators, manufacturers to start employing and manufacturing components like this. So the HRV, I talked a little bit about the HRV. You have this box in the middle, the heat exchanger. The stale air comes out, right? And it goes into that box. The heat from that air is redirected to the incoming fresh air, which is filtered, and then it's supplied to the rest of the building. So for residences, you're supplying it to bedrooms, living spaces, and then you're extracting from the laundry area, from bathrooms, from the kitchen, just as you would in a normal house. It's a little bit more complicated than commercial buildings, but the way that you do it is fairly similar. And the HRVs come in a variety of sizes. There's a number of manufacturers. Zender makes a number of components that are suitable for retrofits, apartments, houses, and small buildings, or you could use them in a distributed method and have several per building, kind of maybe one per floor. Swigon has larger units that are really well useful for commercial buildings. And then Minerga is a Swiss company, and they're manufacturing these massive HRVs that you could actually walk inside. And these are used on large commercial buildings, pools, and gymnasiums, and projects that have a large volume. And it's a, you know, really interesting product. Again, it's something that's difficult to get here in the US right now. And the way that we kind of verify that we have a passive house, there's two parts. One is the blower door test and one is the PHPP. PHPP is the most absurd Excel spreadsheet I've ever seen in my life. The first couple of years with using it, it was, you're basically calculating everything by hand. It was super labor intensive. It wasn't the most effective or efficient way to kind of design projects. And then if you're trying to quickly figure out different assemblies or massing, right, it wasn't the most ideal product for that. Eventually, the PHI, the Passivhaus Institute in Darmstadt, came up with Design PH. This is a plugin to SketchUp where you can model the thermal envelope, and then it kicks out your areas, U values. It basically populates the PHPP for you, so you're not having to do a lot of the back end side of that. You still have to go in and adjust a couple of other things, but it really makes the process easier. What's really interesting to me is that a lot of people now are using Grasshopper or plugging in to Revit or ArchiCAD or whatever they're using, kind of a way of rapid prototyping different Passivhaus models, massing models, and getting a fairly quick means of looking at different buildings and how they would work on the same site. So the blow door test is the other aspect. Like I said, your whole building is air sealed. They'll come through and test the air tightness of the building, and it just has to be under 0.6 air changes per hour at 50 pascals. Another component, this is more of a recommendation, is for a compact building. And with mass timber, I would say that also there are benefits to building with a compact building. There's fewer corners, fewer details to deal with. There's less maintenance, more durability. With a Passivhaus, you get a lot of the same thing. When you have lots of jogs, the building becomes more complicated, the surface area increases, and so you need more insulation to meet the same standard. And so we're constantly striving to make our buildings as compact as possible. What I love about this picture is that it shows, kind of one-story detached houses have a very high form factor. And then my personal favorite, the Blockgrundbebauung, the perimeter block, is a super efficient form factor. Your sidewalls to your neighbors are in adiabatic condition. You're not losing heat left to right, basically, in those buildings. And so you're only having to deal with heat loss, rear, front, top, and bottom under your slab. So there's a wide variety of ways to approach this, but the compactness one is, especially from the mass timber side, from the cost effectiveness, cost durability, things like that, I think is really good. So what are some of the benefits of Passivholz? Well, reduced energy costs, I think, are a great one. We could talk a lot about the differences in energy costs in different regions and how that kind of plays into the equation. But for me, this is a big one. Energy poverty is a huge issue, and this becomes a way of mitigating some of that. There are ways of utilizing the energy cost savings to kind of front load the additional costs borne for meeting Passivhaus. Sometimes it works, sometimes it's close. But for me, this is the big one. This was Seattle last year, probably the worst smoke I've ever seen in my life. This is going to become a bigger and bigger issue on the West Coast, and we're going to have to start addressing the breathability or the inability to breathe. And not even in my lifetime, but today, right now, we should be preparing for this summer. Like I said, the risk of wildfires, it's only increasing. Here in the Pacific Northwest, the Cascades are drying out. All of our smoke, for the most part, this year was from down south. It was from Oregon and California, but eventually we're going to start having a lot more smoke from locally, and at times we get a lot of smoke from British Columbia as well. So with the filtered HRV, we have at least one path of mitigating the smoke, so that when we're in our buildings, we're not having to breathe it. This is a photo from, I believe, Monty Paulson from a couple of years ago after a smoke event. The other aspects that make Passivhaus more functional or livable in these conditions, the air tightness, right? So that smoke isn't permeating into the facade through leaky windows, through a leaky facade. So it really becomes critical, I think, to start thinking and planning and designing for this condition. And for me, it means that public buildings are going to start becoming breathing centers, fresh air centers. We'll have these extended smoke events, and we'll need places for people to go and breathe fresh air. And I really think that, you know, public buildings kind of become the catalyst for some of this. You know, the other aspect too is the urban heat island effect. So in cities with climate change, global warming, our cities are just going to get warmer and warmer. And so we're going to have to start figuring out how we deal and live with this warming condition. Passivhaus reduces the overheating versus a typical building. One of the things that I'm really intrigued by, Monty Paulson up at RDH in BC, and a number of other folks have been stress testing their PHPPs. So the PHPP is based on historic weather data, but you can go through and you can modify the weather data. So you can basically make it warmer to see how your building would function under climate change, under a changing world. So there's a couple of really interesting things that you can start to do to address that as well. The other aspect is, you know, everything in Europe is externally shaded to deal with solar gain. We don't really do a lot of external shades, and if we do, they're usually fixed. I think this is a little bit problematic. In some places it's okay, but I think we need to start addressing the external shading in a big way. I read recently that the city of Vienna is offering subsidies to people so that they can purchase Rolladen, the exterior roll-down shades, specifically for this reason. So we should maybe start thinking about that as well. There are a couple of other things that are interesting with Passivhaus and overheating and climate change. It becomes really difficult with a double-loaded corridor. You don't have the opportunity really to have night cooling. There's not a really good opportunity for cross ventilation. So it might make us start to think a little bit more about how we design and plan our housing. And then the other aspect that I think is really great is we'll have a reduced cooling demand. So physics works both ways. Passivhaus reduces the amount of heat required to heat a building. It also reduces the amount of cooling required. So thinking long term, if you design a building and it doesn't have a need for cooling now, if you need to add it in the future, it would be significantly lower. And then this is just an image of the roll down shades. We had this in Bavaria. We don't have them here, but I grew up with these as a kid. I absolutely love them. You know, another aspect I think with Passivholz, with mass timber and Passivhaus, is that with Passivhaus, your wall assembly is really complicated. It's pretty difficult to build this on site. And so one of the things that we can do is we can build our assemblies for Passivhaus off site. This is also great for mass timber because the longer that our mass timber, you know, CLT decks, glulam framework, et cetera, are exposed to the elements, the higher the risk of, you know, things going wrong. And so buttoning up that envelope quickly and efficiently is really, I think, one of the best things that you can do for both. So I think that there's a lot of synergy in working for this as well. There are a number of outfits in Europe that can do things like this. We have a couple of companies in the US that are moving in this direction. And so my hope is that in the coming years, we won't be quite as far behind Germany on this. Another component that I think is really great is that the mechanical rooms in a Passivhaus can be significantly smaller. So this is the heater for a 25,000 square foot school in the UK. I'm working on a building that's twice as big, and our heating system is significantly larger. And so there's space saving possibilities with Passivhaus that I think could be an opportunity in balancing the cost equation. So you have a better utilization of space. Your mechanical rooms end up being smaller. Your duct diameters aren't as large because you're not having to push as much air through the facility. Your lengths aren't quite as long. You don't have to take that duct and push it all the way to the window, you know, to prevent condensation and stuff on that as well. So you could have this interesting paradigm where the cost of building to Passivhaus ends up being fairly nominal. And of course, it's also great for retrofits. This is a Passivhaus retrofit in Brussels. housing by A2M. I love this. They ripped off the facade and then they came in and put in these new Passivhaus rated components. They added the balconies. The angle of the structure here is designed to optimize the winter sun and block out the summer sun. So it's just a really smart way of working. And again, you can do that in prefabricated mass timber components as well. So I'll talk a little bit about the value added timber industry in Germany. One of the reasons I wanted to move to Bavaria was to kind of be closer to this. I know everyone talks about CLT and DLT, but there's this like whole other world that's going on. And I wish more people knew about it, because I think it solves a lot of the issues that maybe CLT hasn't been that great at solving. So this is a product by Lignator. They're a Swiss company. These really wonderful box beam elements, you can get them as a single box or this gang of boxes. They incorporate the acoustics, thermal insulation, acoustic insulation, fire protection. You can change the material, the wood species, right, and tune that as needed. They can be used for floors, roofs. It's just really kind of simple, elegant solution. And you can get a pretty decent span on that as well. Just a project to kind of show what this looks like. This is the Mori hut in Switzerland, right? So these are the acoustical panels. You can see the slots, the lighting over here, right? So it integrates services as well. It's a really elegant solution. I love this building. And then this little thing here is a vent panel. What this is it's functionally a door, right? So it's a way to get fresh air without having a window. I love this as a solution, pairing this with the large fixed window. And I talk about that way too much in my other life. Another product is the Lignodeca by Lignotrend. This is similar to CLT. Again, it's running services. You can incorporate insulation, acoustic elements, right? So you get a lot more play and variability also in the way that it looks. And then you would install it similar to CLT. It comes in these long panels. You drop them in place, and then you can add the rest of your floor assembly above it. This is a cafeteria in it's a facility for I think handicapped residents in Berlin by Baron Zimmermann. Again, CLT walls, and then the Lignotrend roof. Again, this is the acoustic deck. It's a really elegant solution. You don't have your conduit exposed. I think it just looks amazing. They also make a wall element that's fairly similar. Again, so it's like using CLT, but it's not using as much wood. There's space for running, the services as needed. It's a really simple and elegant solution. They also make this product called UPSI, which these are prefabricated Larsen trusses. A Larsen truss is basically two 2x4s, and then you have these members running between them to separate it. You can use these for retrofits of existing buildings or for new ones, and then you're just packing in insulation, in those cavities. And so it kind of becomes this really interesting way of building these, low energy, low carbon, low embodied carbon retrofits as well. I'd love to be able to go down to Lowe's and pick something like this up. And so while we're talking about decarbonization, my buddy Andrew Mickler talks about this pretty effectively. Is mass timber enough? I'm a little bit leery about the carbon sequestration of mass timber at this point, to be honest. I hope we start seeing more LCAs that talk about it, but I think that we can talk about having lower carbon footprints versus concrete and steel, and we can also talk about decarbonizing other materials in our building. So as our building ages, it requires maintenance, renovations, things like that, new mechanical systems, right? So our embodied carbon, embodied energy aren't static. They're also changing as well. And it's the same with our energy flows, right? So a low energy building Passivhaus would actually be using less energy than this over time versus a standard energy use of a building. So it's important that we not just reduce the amount of energy that we're using, the amount of carbon that is produced in that, but it's also that the building itself, right, that we're addressing those same things. And so there are a number of products available in Germany that have a fairly low embodied carbon. Steico, Gutex, a bunch of other firms. This is basically a byproduct of the timber industry, and they take these panels and fabricate them with compressed wood fiber, and it acts as like a rigid insulation effectively, but it's made of wood and a couple of other materials. Steico also has a blown-in wood fiber insulation, which I think came out a couple of years ago. Again, just like completely blows my mind and what it can do. This is similar to cellulose, but again, it's a byproduct of wood fabrication. Cellulose, we can get this in the US. It's been around for decades. Really great low embodied carbon products. I try to specify this on as many projects as I can. Another really interesting product that came around a couple of years ago was Therma Cork. So the cork industry has had a problem as people have moved towards plastic and metal caps for their wine bottles. The consumption of cork stoppers has gone down significantly. The issue is the trees are still producing all that cork, and so the cork has to be harvested off of the tree, otherwise the tree will die. So there's a company in Portugal that basically takes this excess cork and they have a process of heating it and basically making these thick panels that can be used as we use rigid insulation on a facade, or it could even be an exposed element. So it becomes two things, right? It becomes your siding and your rigid insulation. And so it looks a little bit weird, it smells a little bit weird, but it's I think a really elegant product. And then another product that's really great is Eco Cocoon. Hold on just one second. This is a straw panel that's manufactured in Lithuania. They're, I guess, talking to licensing, they're licensing it to be fabricated in other places as well. Thermally broken, low embodied carbon. You could conceivably use this in multi-story buildings as well. So I think it's a really, really interesting and elegant solution to this decarbonization issue. And so a little bit about me. Presently, I am in the process of trying to figure out how to build my own, hopefully mass timber, multi-story passive house housing. I've been fascinated with Baugruppen since I lived in Freiburg. Baugruppen are effectively co-housing, right? So it's a bunch of people who come together and build their own housing. We're looking at staying in Seattle. For the size, it'll be about 20 homes, a variety of units in those sizes. So right now we have this issue in the city. Everything is really, really small studios, maybe one bedrooms in one building, or expensive, really unfunctional townhomes would be the alternate. And so you don't have this in between. And so we're really thinking about, okay, can we occupy this space? Is there a market to build moderately affordable urban housing, for families like mine? And we've had a lot of good feedback. We're talking to some banks, and hopefully we'll have a little bit more to talk about that in the near future. But for amenities, we're looking at having a communal roof deck. Everyone has their own balcony. Reserving about half the site, as the shared courtyard for garden. Wood fabricator, TBD. Hey, Greg. And for now we're thinking it's a glulam frame. Do we go with prefab floor and wall elements? That's all kind of TBD at this point. For the mobility, we want to be car free. We want to be bike friendly. So we're playing around with the idea of this nice big bike garage like you would see in the Netherlands or Austria, and maybe having one spot on site for accessibility if needed. And of course, aiming for passive house. The issue here in Seattle is there's not actually that many places that you can build multifamily housing, and that's because our zoning effectively looks like this. So most of the city is detached houses, so it's not permissible to build a 20 unit, 3, 4, 5-story building. And then we stick all of our housing, our multifamily housing, on these kind of loud, dangerous, polluted arterials. So as a father of 2 kids that love to play outside, that it kind of kills my soul that we don't have these quieter places that families can live. And again, going back to my time in Europe, right? Like I'm fascinated by density, by car-free areas, pedestrian zones, and green mobility. And so that's where I'm going. But what about where the industry is going? Oh, sorry. And then these are just some of the books that have been influential for me on Baugruppen. So Co-Housing Inclusive by ID22, Michael Lafons, who's a Baugruppe cooperative housing guy in Berlin. The Building and Living in Communities is from an exhibition on communal cooperatives in Zurich a couple years ago. Das Wiener Modell, the Vienna model, really, really elegant book on social housing in Vienna. And then Self-Made City, Kirsten Ring's book with a number of case studies on just incredible Baugruppen in Berlin and surrounding areas. It's just a lovely book. Yeah, so where are we going? This, as an industry, this is a prefabricated mass timber passive house, compact form. It was built in 1997. This is Herman Kaufman, decades before he was doing the CRE or consulting on the 18-story building here at UBC. So we've had this technology for quite a while. So maybe we'll start to see more of it. I'm really fascinated right now with Vincent Calibo as a French architect. His this kind of dense mass timber vision. Again, open space, density, low energy buildings. I'm extremely fascinated by this. The city of Berlin is about to have this huge mass timber passive house eco districts in Tegel. It's the Schumacher Quartier. Again, 5,000 homes, multi-story buildings, lots of open space, mobility hubs for facilitating car-free and car-light living. This is really a way of planning that we don't have in the US or North America. And I think that we're going to see this thing in Europe where we're already seeing it. Districts like this are going to start popping, and they're going to be just incredible places to live, I think. The low energy buildings, mass timber buildings, biophilia, and we're maybe getting 1 or 2 buildings that are mass timber in a district. We don't have mass timber districts anywhere in Washington right now, or I think anywhere in the US. And so, how do we incentivize and facilitate this kind of living, this kind of construction is a big question of mine right now. I'm also really fascinated with the Open Building Co. in the Netherlands. It's a group of Dutch architects who have gotten together and developed their own manifesto. So it's around circularity, design for disassembly. A lot of these buildings are moving towards mass timber, very open floor plans. So this idea that the building is going to be around for 200 years, right? The structure is going to be there for 200 years. How do you design, moderately affordable multifamily housing in urban conditions that can, start to accommodate a lot of these questions? So I think that they're doing really incredible stuff. I think everyone should start stealing their ideas and incorporating them in their own work. It's just fascinating to me. So where do we go from here? Well, I think that the component-based stuff like sidewalk labs is probably the future, and I imagine that in the next 10, 15, 20 years, a lot of what we're going to start seeing is this kit of parts, components-based stuff, and mass timber definitely works really well with that. Passivhaus is easily incorporated into that, and so I really see that that's kind of the direction professionally that I see myself going in, and I think that the industry as a whole is going to start finding itself, and that's where a lot of the innovation is. It'll probably end up being where a lot of the cost savings over time are as well. So that's what I've got. How are we doing on time, Greg?
We're doing great. You speak quickly and cover a lot of territory, which is wonderful. Are you finished? Are you ready for questions?
Yeah.
Okay, great. Let's do it. First from Aaron Schiller. How does the polycarb do with acoustics during rain, etc.?
That's a good question. I imagine it doesn't do that well, but it is multi-walled, so maybe it performs a little bit better. Like I said, I've never been to that place since it was finished being constructed. But I think it's something that you just live with, right? Like you live in a house with a metal roof, right? Sometimes you kind of live with it. So it was definitely a unique thing. And if I go back to the picture, there are some potential building science issues in this as well, right? You can see streaking. It looks like some moisture issues or condensation that could be building up in that panel as well. So it's definitely different. I wouldn't do it, but it's what the client wanted. So.
A question from Mark Devereaux. I'm curious about the combination of Passivhaus, mass timber, and disassembly. With all the adhesives, need for air tightness, etc., how does it impact on the ability to disassemble and reuse at end of life and the associated reduction of waste?
I think this is a really good question. I was thinking about this last night. So there are a couple of different ways to approach air tightness. One is with membranes and tapes. Another would be with like the fluid applied membranes like Prosecco. That stuff works really well, but if you're talking about design for disassembly, it's not the best. Maybe you can take that wall panel and reuse it somewhere else, but if you've sprayed your mass timber assembly with Prosecco, that stuff's not coming off anytime soon. So I look at other projects that have done this in the US and the EU. It's mostly gaskets. So the tapes can come off. You can, I guess, effectively, you could kind of remove the blemishes from the adhesive from the tape over time when you've taken it off. But it is an issue. And then what do you do with the tape? Is it recyclable? Those are really important questions that I think a lot of people are still trying to figure out. I don't necessarily have the answer to that one either right now, but I think it is. I mean, circularity is huge in Europe right now, and so I think that manufacturers will likely have to step up and provide solutions for that.
Another question, John Padilla. What are the best practices and methods in Germany you would like to bring to the US market industry and vice versa?
The one for me is that like every village has carpenter or a wood fabricator shop that could put together those exterior wood panels, fully fabricated, windows installed, insulation, air members, and bring them out to site and installed within a couple of days. That industry is much more prevalent there than it is here. And the thing is, with the circular economy and everything else, Europe is going to start pumping more money into specifically those kinds of things. So, it would be great to have a model that was similar, especially if it's something that can be used not just on single-family houses, but multifamily buildings, commercial buildings. I look at the Bullitt Center that was built here in Seattle a couple of years ago, and almost none of it was prefabricated. Concurrent to that is the Cree building that was built a couple years before that, and almost every component of it was prefabricated. So it's interesting to me that even the greenest buildings here in the U.S. are still light years behind the tech that Europe is working with.
Yeah, I just want to reference that one. Bill Gates in his new book referenced the building here in Seattle as the greenest commercial building in the world, and I think, wow, and that was built what, 7 or 8 years ago?
Yeah.
Next one is Adam Slivers. Regarding the hollow cassettes, Lignatrend, what kind of fire protection materials are used? Are they loose fill? Tall wood provisions in 2021 IBC are focused on GWB, which is labor intensive in concealed spaces.
So it's I believe it's not loose fill. I think it's rigid mineral wool situated in the boxes. This is a huge issue of mine right now, is the the disparity between mass timber buildings, especially on the tall side, between Europe and the US. The encapsulation requirements here, I think, basically make building, mass timber over 85 feet look weird. But, you look at Vienna's ho-ho term, that the CLT decks, the columns, all that stuff is exposed. I think the same with Starnet in Norway. And so you're going to have this weird disparity where tall timber in the US can be done, but you're going to lose, I think, a lot of the amazing benefits of mass timber and that you'll be able to enjoy in Europe. So, hopefully there's a way to, over time, synthesize those two. I don't know if it means we adopt Euro norm codes, but it is a significant issue.
Okay, Lloyd Alter asked, what is the cost comparison for those cellular floors? There's more work, but less wood.
What do you know what he means by these cellular floors? I'm guessing it's these. I would imagine it's a little bit less expensive than CLT. There's less fiber. I think the spans are pretty comparable, but that's a good question. I'm not quite sure.
Okay, Mariam Farzan asks, some passive houses perform very well during winter, but can be uncomfortably warm during summer months in a European context. What is your recommendation to deal with this problem?
Oh man, this is a good one. The overheating in a passive house, especially in summer, can be an issue, especially if it's not, like I said, stress tested in the design phase. In the US, it's really easy to add cooling. In Europe, cooling, especially in Germany, I think only 3% of homes have air conditioning, or 4% at this point. So the cooling issue is going to become a bigger issue, and it's going to require, the low GWP solutions for the coolant as well. That's a good one. I would say stress test your PHPP. Look at maximizing your shading so that you're not getting a lot of direct sun or even indirect sun in the summer months. Use cross ventilation, night cooling where possible.
Hey, here's a question from Lloyd Alter. Makes me smile. You ready? Here's the question. What are the main reasons that they are so innovative in Europe and we are so backwards? Why don't we do this?
Apparently, I'm writing this exact article for Lloyd in the next couple of weeks. I think part of it is honestly legislation. So the European Prime Building Directive and the Nearly Zero Energy Building Directive in Europe has really changed the way a lot of cities have approached this issue. In the US, the cities are losing the ability to have a say on the energy codes. So I think part of it is codes. In the US, our codes are written by a nonprofit. In Europe, codes are written by the government. And so the government can say, okay, this is what we need, this is what we're going to do. And it's not so straightforward in the US. And so it's difficult also politically for a city like Seattle to say, okay, all of our public buildings have to be Passivhaus. Well, you have cities all over Europe that have done this over the last 10 years. And so, the city of Freiburg's new mass timber city hall needs Passivhaus, and it's huge and elegant, and it even incorporates a kindergarten. I think that the codes are a big part of it. I think building culture is also a part of it. I don't know the exact answer, but it's definitely frustrating because it definitely feels like we are backwards.
Okay, a question from Aaron Marks. In the absence of better zoning, regulation, and formal incentives, do you think developers can sell the kinds of projects you're talking about to communities with variances that allow the projects to pencil?
I want to say yes, because that's the space I would like to be in. But it's a good question. I'm not a fan of zoning in general. There's not really zoning as we call it in Europe or even Asia. There's certainly no single family zoning through most of Europe. There's none in Japan. The zoning question is a big one. It's, if the cost of land to build multifamily housing is skyrocketing because there's huge demand and no place to do it, and jurisdictions aren't going to be proactive in their land use policies like they are in a lot of European cities, it will probably be very difficult.
Here's a comment or a question from Lech Muzinski. Could you send a link to the Dutch group? All right, could you tell us how to find it?
Yeah, I think it's openbuildings.co is the website, and they have case studies. They've got their manifesto, which I highly suggest looking over. And those architects, Tom Franson, all those guys are they're doing really incredible work. And some of it is moderately affordable. It's flexible, mixed use. You could have one of the buildings, Blackjack, has I think a hotel, apartments, office space, and maybe a cafe, like all in the same building, right? So it's just having buildings that can accommodate such a diversity of uses, I think is amazing.
Well, this is just a comment, but from Veronica, prioritizing science would be a start.
Yeah, hopefully we're getting to that, but yeah.
Another one from, I think it's from Lloyd. John Habrecken came up with it. Ted Benson developed an American version.
Yeah. So Jan Habrecken is the Dutch architect that is kind of influential to the guys at Open Building. Ted Benson, I guess, is the Benson Wood and Unity Homes. Habrecken and his colleagues were doing these amazing large cooperative projects where people could come in and effectively co-design their unit that was in the, there's a framework to it, but they could come in and they would have one or two sessions with the architect to kind of, configure their layout. And, that's kind of the direction that, that we're trying to go with our Baugruppen as well as, we're not going to be like the Germans where it's democratically designed. The entitlement process in Seattle takes years and years and years. We just don't have time to spend years and years and years designing a building, then years and years and years getting it permitted and then building it, right? So we'll have this expedited kind of variation on the Baugruppen, but definitely having something, in the guise of Open Buildings where it's, flexible, you can move partitions, flip things around, and you just have these cores that everything kind of draws back to for plumbing and MEP and stuff. So
well, here's a question from me. Our next presenter in half an hour is Eve Picker of Small Change, who's really focused on crowdfunding. And in the mix of prefab, mass timber, Passivhaus, and the Baugruppen communities you want to build, what about mixing up crowdfunders who may want to live there or at least invest there if they don't want to live in that particular location? Maybe that can be mixed in some way.
Oh no, it's definitely in the long term something that we've been discussing as a possibility. We're also interested in talking to social impact investors to work out the front end. So I think that there are a couple of options, but yeah, Eve's Small Change. They're doing some really innovative stuff and super affordable stuff as well. So it's definitely a model that we've been looking at.
I'm going to propose that even starting here in the Pacific Northwest, Stephanie Gripney of Impact Finance Center is collaborating with Eve Picker. So we're mixing impact investors with crowdfunding, and there have to be mixes of that could potentially work here where we have so much housing demand and so much wood.
Yeah.
So we'll follow up with that afterward. Here's, I guess, my question. You gave a lot of information. This will be shared on YouTube. But what do you recommend people connect with you and connect with resources about all these products, about how the industry is changing? What do you recommend?
Reach out to me, definitely. You can find me on LinkedIn. My email was in the presentation. These are elements that I've been talking about for years and years and years. Finally at the point where I think we're starting to see the feasibility of some of them. If you want to know more about these products, about like how I as an architect would use these products, definitely reach out to me. I can kind of let you know how I feel about them, how much I'd love their availability, or if you want to, questions about Passivhaus, potential projects, I'm always open. So.
And a final question, lost in translation. I mean, you've lived and worked in Germany and in Europe, and there's so much happening within German-speaking media and the industry, and so much doesn't make it here and to other countries. Just the English-speaking world or other countries. How do we expedite, or how do you make those connections, bridges, so good ideas, good products, good services travel more quickly across borders?
This is a really good question. This is part of the reason that we moved to Germany, was I wasn't sure that the possibility would ever happen here for a lot of these things. I think it's the cross-national cooperation. We need a platform so that the Swiss, the ETH can talk to people here, so that people here can talk to the Finns or the Norwegians about all of the, their mass timber districts. Like the Europe is pretty good at knowledge share within Europe. And we're not very good at knowledge share here in the US. I don't think. We all kind of build these silos. And so having this kind of cross-national, cross-industry platform, to me would be a really good educational tool that you could point to. But a big issue I think that we have is we don't have built examples to take people to, right? Like there's not mass timber. We don't have a single mass timber public building in Seattle. We don't have a single public Passivhaus project in Seattle. We have one Passivhaus multifamily project in Seattle. So it's really difficult to say, hey, look, this is the future of construction, without having those examples, I think, locally that people can see. So it's a difficult question, but I think that navigating the right solution would definitely open up more discussions. The translation thing too is really difficult. There's so much good information. It's only in German. I don't have any time to translate any of it, but maybe there's an entity out there that would be willing to translate it so that people have access to it. I mean, that's the only way I know about most of this stuff, is from reading German reports and articles. So.
Thanks for that. I'll kind of leave with that, then ask the audience. There is a need, I agree with you, for an organization, or why aren't we connecting virtually on the web? I had Peter Finholm speak about the Nordics as an earlier presenter, and then we'll be covering this topic on Saturday after the keynotes in a panel. But certainly I'm interested, and I bet you are as well, where there's an organization that actually has board members and advisors and participants from the EU, from North America and other countries, who see business opportunities in sharing that information and in forging those connections, because almost all existing wood organizations and timber organizations within Europe and the US don't have membership across from both continents. Yep. So hopefully we can help make that happen.